Assalamu alaikum wa rahmatullahi wa barakatuh. I am Hussein Ali Al Khatti from College of Business Administration in Imam Abdurrahman bin Faisal University. Thanks for Dr. Maqsood Khan for giving us this opportunity to talk about one of the trending topics related to our course, Database Management System. The topic today is NoSQL, and I will talk about it in details in these slides. The objectives of my topics are define NoSQL, SQL with NoSQL, examples of NoSQL, NoSQL family, NoSQL performance, handling relational data, why and when to use NoSQL, and the benefits and challenges of NoSQL. So now I will talk about what is NoSQL. NoSQL is a non-relational database management system that doesn't require a fixed schema, avoids joins, and is easy to scale. NoSQL database is used for distributed data stores with homogeneous data storage needs. NoSQL is used for big data and real-time web apps, for example, companies like Twitter, Facebook, Google, that collect terabytes of users every single day. NoSQL database stands for not only SQL or not SQL, and it was introduced in 1998. Another terminology of NoSQL is an approach to database design that can accommodate a wide variety of data, including key value, document, columnar, and graph formats. NoSQL, which stands for not only SQL, is an alternative to traditional relation database, in which data is placed in tables and data schemas is carefully designed before the database is built. One of the main objectives about my topic is SQL versus NoSQL. Here, I will compare between these two. SQL databases are primarily called Relational Database Management System or relational databases. NoSQL databases are primarily called as non-relational or distributed database. SQL designs for traditional relational database management system and uses SQL syntax and queries to analyze and get the data for further insights. Also, they use the OLAP systems. On the other hand, NoSQL database system consists of various kinds of database technologies. These databases were developed in response to the demand presented for the development of the modern applications. The query language used for SQL is structured query language, and for NoSQL, non-declarative query language. For the type, SQL databases are table-based databases. NoSQL databases can be document-based, key-values pairs, graph databases. For the schemas, SQL databases have a predefined schema, and NoSQL databases use dynamic schemas for unstructured data. For the ability to scale, SQL databases are vertically scalable. NoSQL databases are horizontally scalable. Another main objective of my topic is examples of NoSQL. NoSQL is a category which then divided into three categories: key value store database, tabular database, document-oriented database. Key value store databases have examples such as Mechamid, Currents, and Redis. The tabular database have examples such as Bigtable from Google, HBase, Acumulo, Couchbase. The document-oriented databases have examples such as MongoDB, which is the most used, and CouchDB, Cloudant, ArangoDB, Amazon DynamoDB. Here I will talk about the NoSQL family. The first member of the NoSQL family is the document database, also called document stores. Stores semi-structured data and description of that data in document format. They allow developers to create and update programs without needing to reference master schemas. Use of document database has increased along with the use of JavaScript, a data interchange format that have gained wide currency among web application developers. Although XML and other data formats can be used as well, document databases are used for content management and mobile application data handling. Another member of the NoSQL family is the graph. Graph stores, or the graph data stores, organize data as nodes, which are like records in relational database, and edges, which represent connection between nodes because the graph system stores the relationship between nodes. It can support richer representation of data relationships. Also, unlike relational models reliant on strict schemas, the graph data model can evolve over time and use graph databases as applied systems that must map relationships, such as reservation system or customer relationship management. Another member of the NoSQL family is the key value. The key value stores or key value databases implement a simple data model that bears a unique key with associated value. Because this model is simple, it can lead to the development of key value databases, which are extremely performant and highly scalable for session management and caching in web application. Implementation differ in the way they are oriented to work with RAM, solid-state drivers, or disk drivers. The last member of the NoSQL family is the white column. The white column stores organized data tables as columns instead of rows. White column stores can be found both in SQL and NoSQL databases. White column stores can query large data volumes faster than conventional relational database. A white column data store can be used for recommendation engines, catalogs, fraud detection, and other types of data processing. Here we have a table illustrating the performance for NoSQL in terms of performance, scalability, flexibility, complexity, and functionality. For the key value, we have a high performance, high scalability, high flexibility, and none for complexity and variable functionality. For the document, we have high performance, variable scalability, and also we can consider it as high, and high flexibility, low complexity, and low functionality. For the column, we have high performance, high scalability, moderate flexibility, low complexity, and minimal functionality. For the graph, we have variable performance, variable scalability, high flexibility, and high complexity, and graph theory for the functionality. For the relational, we have variable performance, variable scalability, low flexibility, moderate complexity, and relational algebra for the functionality. Here comes the question, how we can handle the relational data. Since most NoSQL databases lack ability for joins and queries, the database schemas generally needs to be designed differently. There are three main techniques used for relational data in a NoSQL database, which are multiple queries, caching, replication, and non-normalized data, and nesting data. For the multiple queries, instead of retrieving all the data with one query, it's common to do several queries to get the desired data. NoSQL queries are often faster than the traditional one. Also, we can have an excessive number of queries would be more necessary to reach the desired goal. For the caching and replication and non-normalized data, instead of only storing foreign keys, it's common to store actual foreign values along with the model's data. For example, each block comment might include the addition to a user ID, this providing easy access to the username without requiring another lookup. When a username changes, however, this will not need to be placed in the database. Thus, this approach will work better when reads are much more common than the writes. For the nesting data, with document database like MongoDB, it's common to put more data in smaller number of collections. And this is the way to handle the relational data in NoSQL. Why and when to use NoSQL? Why use NoSQL? Modern NoSQL solution can tackle applications that require a high degree of scalability, data distribution, and continuous availability. We should also understand that relational databases have been used for transactional processing in organizations for a very long time. Relational database management system is supported by several tools and a large trained workforce that implements and maintains them. The need to find an alternative to relational database management system is technical and functional and perhaps financial. When to use NoSQL is when traditional relational database is not enough, and when the data which is needed is flexible schemas, and the constraints and validation logic not required to be implemented in database. Also when logging data from distributed sources, and it should be used to store temporary data like shopping carts, wish list, and session data. We have a large number of benefits and challenges of NoSQL. The benefits of NoSQL such as it's a scale, horizontal scale, and it has a simple data model, and we can have a volume and streaming, reliability, schemaless, rapid development, flexible as it can handle semi-structured, unstructured, and structured data, and it's cheaper than the relational database, and it's create a caching layer, and it's wide data type variety, and uses large binary objects for storing large data. And for the challenges of NoSQL, we have challenges such as we cannot use SQL, the ecosystem, tools, and add-ons, and we cannot perform searches, and we might have a data loss, and we might have no referential integrity, and the lack of availability expertise. To sum up my topic, NoSQL database uses a variety of data models for accessing and managing data. These types of database are optimized specifically for applications that require large data volume. Also, we mentioned the types of NoSQL in this topic, which are the key value, document, white column, and graph. Also, we use NoSQL for its flexibility, scalability, high performance, and highly functional. Here we come to the end of our topic. Thank you for listening, and goodbye.